Assalamualaikum and hello. In this video, our group will be present Malaysian cultural arts and geometry with the theme Lukisan Batik. Our chosen object is kain batik, which is a textile art rich in heritage. Batik is from Jawa word. Tik means dots and ambatik means draw or color. Kain batik was actively produced in early 20th century, centered at Kelantan and Terengganu as production hub. Kain batik made by wax resist dyeing method on cotton. In this process, melted wax is carefully applied to selected area of cotton or silk fabric by using chanting tools or brush. The wax acts as a barrier, prevent dye from getting passed through these parts. After dyeing, the wax is removed by scraping or boiling, reveals patterns and vibrant contrasts. These techniques allows artists to create symmetrical motif and repeated geometric shapes inspired by nature and Malay traditions. The chosen kain batik is owned by one of the overseas students. The kain batik is usually worn as women traditional attire, for example, sarong, kebaya, and baju kurung. The kain batik is usually worn for ceremonial occasion or formal events to show national identity of Malaysia. The object includes 1.08 length and 0.83 wide, usually wear as sarong for women. This picture shows the object of the study. What is a geometric shape of this object? Now proceed to geometric part.
In this section, I will explain the geometry found in our kain batik. The batik pattern contains several geometric shapes such as irregular pentagons, circles, and irregular quadrilaterals. These shapes are repeated throughout the design and create an attractive pattern. The arrangement of this shape forms a tessellation pattern, which means the shapes is together repeatedly without leaving gaps or overlapping. The repetition of the geometric shapes also create balance and symmetry, making the batik fabric look more beautiful and organized. Now, let's look at the geometric shape found in the batik fabric. This kain batik contains various two-dimensional or 2D shapes. Since the design is printed on a flat surface, there are no clear three-dimensional or 3D shape present. The first shape identified on the kain batik is an irregular polygon. The shape has 5 sides with length of 2.5 cm, 2 cm, 2.5 cm, 2.5 cm, and 3 cm. Since the side lengths are not equal, it is classified as an irregular polygon. And the second one is an irregular quadrilateral. It has 4 sides measuring 1 cm, 1.2 cm, 2 cm, and 1.9 cm. Because the side lengths are different, so the shape fulfills the characteristic of an irregular quadrilateral. And the third shape found in the kain batik is a circle. The circle has a radius of 0.3 cm. A circle is a two-dimensional shape where every point on its boundary is the same distance from the center. Therefore, this shape fulfills the characteristic of a circle. And the last one is an irregular octagon. The octagon has 8 sides with length of 3.5 cm, 4 cm, 3.7 cm, 3.9 cm, 3.8 cm, 4 cm, 3.5 cm, and 3.9 cm. Since the side lengths are not all equal, it is classified as an irregular octagon. These geometry shapes are arranged in a repeating tessellation patterns, which contribute to the beauty and uniqueness of the batik fabric design. Next, we move to geometric concept.
In this part, I will discuss further with the geometrical concept of each of the shapes that has been explained in section 2.1. Besides, I will also explain and show the measurement of the shapes and the concept of geometry that we learn in class. Based on the kain batik, we will find and calculate the measurement, angles, perimeter, and areas of the shapes.
First, let us look at the irregular pentagon. This shape demonstrates that a geometric figure does not need to be perfectly regular to follow mathematical laws. Although its side lengths and interior angles are different, its perimeter can still be found by adding all the side lengths, giving a total of 30 cm. The interior angles are all different, but together they still add up to 540 degrees. Since the shape is irregular, its area of 10.47 cm square was calculated by dividing it into 3 triangles and applying Heron's formula to each triangle. The areas were then added together to obtain the total area. Because its sides and angles are unequal, the shape has no rotational symmetry. It means if you rotate it, the sides and angles will not match its original position at any angles less than 360 degrees, so it never repeats its shape. This shows that irregular shapes can still follow geometric principle and mathematical calculation. Next, we analyze the irregular quadrilateral. This general for side-shaped features sides of entirely different lengths, giving it a total perimeter of 6.1 cm. It contains a distinct 90-degree angle, which introduces a right angle and connects to the concept of perpendicular lines. The interior angles are all different, but together they add up to 360 degrees because its interior angles vary. It is classified as an irregular quadrilateral. To calculate its total area is 2.05 cm square accurately. The quadrilateral was divided into 2 triangles. Heron's formula was then applied to find the area of each triangle before combining them to obtain the total area. Moving on, we explore the circle. The circle represents perfect rotational symmetry because it has absolutely no edges or vertices. All of its geometric measurements, such as its perimeter of 1.88 cm and area of 0.28 cm square, depend entirely on the length of its radius. The relationship between its circumference and area shows how the mathematical constant pi is used to connect straight and curved measurements. Finally, we have the irregular octagon formed by the repeating batik pattern. This shape demonstrates that a geometric figure can resemble a regular shape while still having unequal side lengths and angles. Its perimeter is 30.3 cm and its interior angles are close to 135 degrees. The interior angles are not all equal, but together they add up to 1080 degrees. This shows that the batik pattern is inspired by regular octagon while still having artistic variation. To find its area of 69.76 cm square, the octagon was divided into triangles and rectangles. Heron's formula was used for the triangle section, while the standard area formula was used for the rectangular section. These areas were then added together to obtain the total area. Then, we will move to the part of transformation.
Before you go any further, what exactly is a transformation? In geometry, a transformation is a process that changes the position, size, shape or orientation of a two-dimensional figure. Transformations are crucial because they help us understand the relationship between shape. Furthermore, they are widely used in art, design and everyday application, such as in the creation of batik fabric. Generally, there are 3 types of basic transformation that we will discuss today: translation, reflection, and rotation. Let's look at them one by one. First, translation. This is the movement of all points of a figure from one position to another in the same direction and by the same distance. Its main characteristic is that the shape does not rotate, flip or change size. It simplifies shift place. Second, reflection. This is transformation products a mirror image of a shape across a straight line, known as a line of reflection. The left side becomes the right side on the image. Third, rotation. This is the movement of a figure spinning around a fixed point called the center of rotation through a specific angle. The rotation can occur in either a clockwise or counterclockwise direction. Next, let's see how this mathematical concept are applied to our culture art, which is batik. Before that, we need to know what a motif is. A motif is an angle decorative element, for instance, a floral or geometric motif. When this motif changes its position or direction without changing its original shape, it creates variation. For example, translation of a motif. A flower motif is shifted to the side without altering its size or direction. Reflection of a motif. The motif is flips across a line of reflection to create a symmetrical mirror image. Rotation of a motif. The motif is turned around a fixed point at a certain angle, giving the design a dynamic effect. Moving on, from that single motif, we can construct a complete piece of batik fabric through a pattern. A pattern is an organized repetition of motif. It is the transformation within this pattern that create rhythm, balance, harmony, and beauty in batik fabric. Pattern translation, a repetition pattern that slices horizontally or vertically. We often see this on the hem leg of the fabric of a border strip of batik fabric. Reflection of a pattern. The pattern is a mirror across a line of reflection, creating a balanced design on both the left and right side. Rotation of a pattern. The pattern rotates across a central point. We can see an example in the diagram where a branching line motif rotates to form a circular or radial patterns from the center. So I will pass to the conclusion.
For summary, kain batik is a cultural legacy textile art. It is widely worn by Malaysian women, including female university students, as daily sarung at home. Specifically, in our chosen kain batik, there are some geometric shapes in the batik pattern, such as irregular polygon, circle, and irregular quadrilaterals. Within this geometric shape, we can identify various geometric concepts like measurement, perimeter, area, and angles. Finally, the motif and patterns show geometric transformation, namely translation, rotation, and reflection. In conclusion, this task has deeply enriched our appreciation for the subtle integration of geometry within our daily life. Exploring the intricate patterns of the traditional kain batik revealed that geometry is not just an abstract classroom concept, but a living art form woven directly into our cultural heritage. From the precise angles of irregular polygons to the rhythmic movement of motif through translation and reflection, we now see how structural symmetry and spatial reasoning shape the everyday object around us. Ultimately, this experience proved that geometry acts as a visual language connecting academics to the beauty, culture, and functional designs of the real world. That's all from us, Group 1. Thank you.